The airport is underwater, the highway is a river, and the city that built the world's tallest tower cannot stop the rain. What happened to Dubai on April 16, 2024 was not supposed to be possible. Not here. Not in a desert city where annual rainfall averages less than 100 millimeters, where entire years pass without a single significant storm. But in less than 24 hours, the sky delivered more water than most residents had seen in their entire lifetime. And the infrastructure of one of the most modern, most expensive, most meticulously engineered cities on the planet simply had no answer for it. This is the story of that day. What fell from the sky, what broke beneath it, and what it means for a region that may never be the same again. The first alerts came quietly. The UAE National Center of Meteorology issued rainfall accumulation warnings for eastern and northern areas in the hours before the event. Dubai police broadcast safety advisories urging residents to avoid beaches and low-lying valleys susceptible to flash flooding. To anyone who had lived in the Emirates for years, warnings like those were routine, the kind that arrive, linger briefly on a phone screen, and disappear without consequence. The desert rarely followed through on its threats. This time, the desert had nothing to do with it. What arrived on the morning of April 16th was a deep, slow-moving, low-pressure system that had originated over the northeastern Mediterranean and drawn moisture from the Arabian Sea and the Gulf of Oman as it moved through the region. By the time it reached the UAE's eastern coastline, it had organized into something meteorologists would later describe as the most violent storm the country had seen in decades. It did not arrive with the dramatic theatrics of a hurricane or the spiraling fury of a typhoon. It arrived the way catastrophe often does, gradually, then all at once. By early afternoon, rainfall rates at Dubai International Airport were climbing beyond anything the instruments had reliably recorded. Over the span of a single day, Dubai recorded 142 millimeters of rain. At Al Ain, the inland city near the Omani border, that number reached 254 millimeters, the highest total since rainfall records began in the UAE, more than 75 years ago. In a city where the annual average rainfall at the airport is approximately 97 millimeters, and that single storm delivered more than 2.5 times the expected rainfall for an entire year within 24 hours. But that's only part of the story. To understand why Dubai flooded the way it did, why highways became channels, why underground tunnels became sealed chambers of brown water, why one of the world's busiest airports was thrown into chaos, you have to understand the shape of the city itself. Dubai is flat. Extraordinarily flat. It was built on sand, reclaimed from the desert and from the sea, engineered upward into gleaming towers and lateral into sprawling road networks, but never fundamentally regraded or reshaped to accommodate water. The city's drainage infrastructure was designed for the climate that existed when it was built. A climate where significant rainfall was, statistically speaking, a once-in-a-generation event. Storm drains were sized accordingly. Pumping systems were calculated against modest projections. The entire hydraulic logic of the city rested on an assumption that has, in recent years, begun to crack. When 254 millimeters of rainfall descends onto a flat, sealed urban surface in less than a day, the water has nowhere to go. It cannot percolate into sand beneath concrete. It cannot drain through systems engineered for a fraction of that volume. It pools, it spreads, it finds every depression, every underpass, every low-lying road junction, and it fills them steadily, relentlessly, indifferently. Sheikh Zayed Road, the arterial spine of the city running 7 to 8 lanes in each direction. The highway that connects Dubai from one end to the other and carries hundreds of thousands of vehicles every day became impassable. Vehicles, sedans, SUVs, luxury cars, delivery trucks, were abandoned in place, their doors level with rising water, their engines silent. Aerial images captured the surreal geometry of a modern city grid turned inland sea, with the upper floors of buildings still gleaming, while the streets between them had disappeared beneath a brown, slowly churning surface. Al Khail Road suffered the same fate. Metro stations reported flooding, residential buildings in lower-lying districts reported water entering ground floors. Tunnels sealed completely. And then there was the airport. Dubai International Airport is the busiest international hub on the planet by passenger numbers. Yet in 2023 alone, it processed approximately 87 million passengers. It is a city within the city, a permanent, pressurized system of movement, logistics, and commerce that operates 24 hours a day, 365 days a year, and has contingency plans for nearly every conceivable disruption. It had no contingency for this. Operations were briefly halted, with arriving flights diverted for a prolonged period and disruptions cascading across international flight networks for days. Thousands of passengers were stranded inside the building or in aircraft that could not move. The airline industry absorbed the reverberations for days afterward as rebooking cascades rippled through international flight networks from London to Mumbai to New York. The airport provided free hotel accommodation for stranded travelers, a gesture that revealed the scale of a disruption no one had fully planned for. Yet, what came next reveals something even more unsettling about this event. The same weather system that hammered Dubai crossed the border into neighboring Oman with equal force. And there, the consequences were lethal. At least 19 to 20 people died in Oman from flooding associated with the same storm. The topography is different there. The terrain more dramatic, the wadis deeper and faster filling. When flash floods surge through dry riverbeds that have not seen significant water in months or years, they move with a violence that urbanized, flat terrain never quite replicates. Nearly 20 lives erased in hours by the same system that was turning Dubai's highways into slow, on still lakes. In the UAE itself, 5 deaths were confirmed. 3 Filipino nationals, an elderly Emirati man, and a Pakistani man. That the casualty count inside the country remained relatively low, given the scale of the inundation, is a testament in part to the speed of the government response and, in part, to the relatively slow nature of the flooding itself. This was not a fast-moving wall of water. It was an overwhelming accumulation, relentless, deep, and blinding, but survivable if you stayed out of its path. The UAE National Emergency Crisis Management Authority activated full emergency protocols. Dubai police deployed alongside military units using pumps, specialized vehicles, and water tankers to begin clearing the most critical road sections. Rescue teams navigated flooded streets in vehicles equipped for high water, extracting stranded motorists from cars that had become isolated islands. The Ministry of Interior fielded thousands of emergency calls, the majority related to stranded vehicles and water entering homes and commercial buildings. The response was real, organized, and effective. And still, it took days for the water to fully recede. NASA's Global Precipitation Measurement Satellite tracked the event from above, capturing the rainfall totals that confirmed what ground-level sensors had already recorded. NASA Earth Observatory published satellite imagery on April 19th, showing the extent of standing water across the urban landscape. Imagery that would be viewed, shared, and studied by meteorologists, urban planners, and climate scientists around the world for months afterward. And now, scientists fear history may be repeating itself. And because this was not the first time the UAE had been caught off guard by rain. In 2008, a rainfall event delivering more than 100 millimeters caused significant disruption across the Emirates. At the time, it was treated as an outlier, an anomaly from which lessons could be learned and preparations made. The drainage systems of that era were inadequate, the emergency protocols underdeveloped. More than 15 years passed. The country grew richer, taller, more connected, and more sophisticated in nearly every measurable way. And when the rain came again in 2024, it found the same fundamental vulnerability waiting. The flat streets still drained slowly, the storm systems were still sized for a drier past. The assumption that the desert's hostility to water was a permanent geographical fact had not yet been fully abandoned. That assumption has a name in climate science: stationarity. It is the idea that the statistical distribution of weather events, the range of what can be expected, the frequency of extremes, remains stable over time. Climate scientists have been arguing for years that stationarity is dead, that the historical record of rainfall, temperature, and storm frequency can no longer be used as a reliable guide to the future. The April 2024 event in Dubai did not merely challenge that assumption, it obliterated it in real time in one of the most photographed and documented cities on Earth. The Arabian Peninsula is warming faster than the global average. Sea surface temperatures in the Arabian Sea and the Persian Gulf have risen measurably over recent decades, and warmer ocean water feeds more moisture into atmospheric systems passing above it. When a low-pressure system now draws on that reservoir, it draws on more of it than it would have 50 years ago. The storms don't necessarily become more frequent, but when they arrive, they carry more. They hold more water in suspension. They release it faster and harder. What meteorologists observed on April 16th was a storm that, by some models, should occur perhaps once every 75 years or more. A so-called return period, but those return periods were calculated using historical data from a different climate. In a warmer world, a 75-year event does not wait 75 years. It becomes a 50-year event, then a 30-year event, then something that happens in your lifetime more than once, with consequences each time that your city was not built to survive. The financial damage from the April 2024 flooding has never been officially quantified by the UAE government. Estimates referenced in regional reporting speak of figures running into the billions of dirhams. Damage to vehicles, infrastructure, commercial property, residential buildings, and the compounding economic cost of prolonged disruption at the world's busiest international airport. Those numbers, if and when they are formally published, will represent more than a balance sheet. They will represent the cost of building a city for the climate of the past and meeting the climate of the future, because what happens next could rewrite how this region thinks about itself entirely. The UAE is not a passive country. It reacted to the 2024 floods with the same engineered ambition that built the Burj Khalifa and the Palm Jumeirah. Government officials acknowledged the drainage shortfalls publicly. Urban planners and civil engineers were convened. Discussions about expanded storm drainage capacity, improved early warning systems, and revised infrastructure codes entered official planning channel. The scale of the political will is not in question. What is in question is the scale of the problem. Retrofitting a drainage network beneath one of the world's most densely built and rapidly growing urban environments is not a project measured in months or even years. It is a multi-decade undertaking, yet requiring excavation beneath a city that never stops moving, recalibration of systems designed for different conditions, and investment that competes with every other priority a fast-growing nation carries. And while that work proceeds, incrementally, necessarily imperfectly, the atmosphere continues warming. The Arabian Sea continues absorbing heat. The atmospheric moisture content above the region continues climbing. The return periods for extreme rainfall events continue compressing. There are no easy answers here. The scientists who study this system know that. The engineers who manage Dubai's infrastructure know that. And the residents who watch their cars disappear beneath brown water on Sheikh Zayed Road on a Tuesday afternoon in April 2024 know it in a way that no satellite image or rainfall chart can fully communicate. What experts are struggling to resolve is this: at what point does adaptation become inadequate? At what point does the engineering solution fail to outpace the physical reality? The UAE has the financial resources, the technical capacity, and the governmental coherence to respond to this challenge more effectively than most countries on Earth. And yet even those advantages do not eliminate the underlying equation that a desert city of more than 3.5 million people built on flat sand in a warming region is now facing a category of extreme weather event that its founders never contemplated and that its current infrastructure was never designed to absorb. The water receded by April 20th. The roads reopened. The airport resumed operations. The abandoned cars were towed. The city, to its enormous credit, recovered with a speed that few places could have matched. But the system that produced that storm has not gone anywhere. The atmospheric conditions that made it possible are not a historical anomaly. They are a trajectory. And the next time the moisture loads correctly and the pressure drops in the right location at the right time of year, Dubai will face that question again. Whether the city's drains will be ready for it is one question. Whether the city's assumptions about its own future will be ready for it is another. And that second question has no engineering solution. Stay curious about the ground beneath your feet and the sky above the cities we build beneath it.